Good morning to all of you. In a previous session, we have seen analysis of discrete time, linear time invariant system, and we have discussed that there are two methods for analyzing given DT-LTI system. Okay, first one is direct solution of the given input-output equation, that is difference equation, to identify the response of that system, and second one is representation of given input signal by using elementary discrete time signal. With the use of convolution summation formula, we can identify the response of the system, right? So analyzing any DT-LTI system means we are simply identifying its behavior. That means we are identifying the output or response of the given DT-LTI system. Okay, so convolution summation is one of the method to analyze or to identify the response of given DT-LTI system. So to identify convolution summation, as we discussed in the previous session, how that convolution formula is derived, right? So we derived the convolution formula there, but there are various methods to identify the convolution of given input sequence with the impulse response, right? So by using convolution summation, you can identify the response of the system. So there are four methods to identify the convolution sum. That is nothing but first method is the graphical method, second one is the mathematical method, third one is the tabular, and fourth one is the matrix method. So out of these four methods, today we will be discussing graphical method to identify convolution summation, ultimately identifying the response of the given DT-LTI system. Okay, so in this session we will be solving two different problems to identify the response of system. Okay, so here is the first example. Okay, so as you can see in this example, what has been asked, the impulse response of LTI system, DT-LTI system is h of n is equals to. So this is the response produced by the system when you are giving to the system del of n as an input. So it will produce response as h of n. Okay, so we're using same system. So if you are applying impulse response to the system, then system will produce this impulse response, sorry, unit sample sequence to the system, then it will produce this impulse response. And using this impulse response, we can identify the response, overall response of the system for any given input. Okay, so in this example, we have to determine the response of the system to the input signal x of n. Okay, so in any problem, you will be provided with the impulse response and the input sequence, and you have to identify the response of the system. Response of the system is you have to identify y of n. Okay, so as we had discussed in the previous session, right, here what you have provided with, you have provided with impulse response and the input signal. Okay, from that you have to identify the output or the response of LTI system, that is nothing but y of n. And as we had discussed in the previous session, the y of n by using convolution summation can be identified by using convolution summation formula. Okay, so the convolution summation is given by, what is the formula for that? Y of n is equals to summation k is equals to minus infinity to infinity x of k into h of n minus k. Okay, so this is the formula for identifying the overall response of the system by using input sequence and the impulse response. Okay, so this is the formula, but we want to solve this example by using graphical method. But before solving it, we should identify how many samples will be there in the output sequence. Okay, total number of samples. Okay, so what will be the minimum value of n and what will be the maximum value of n. So if you observe these two given sequences, in impulse response, the minimum value of n is -1. Okay, because at origin 2 is present, that means here the value of n is 0. Okay, in this case it is 0, n is equals to 0. So at n is equals to 0, value 2 is present. Okay, because it is origin. Okay, it is represented by upward arrow. At n is equals to 1, 1 is present. Okay, and n is equals to 2, -1 is present. And on left hand side of origin, at -1, 1 is present. Okay, so the minimum value of n in this case is -1, that is the start limit is -1, and the end limit is 2, right? Similarly here, n is varying as what, as it is a origin sample, so it is nothing but n is equals to 0. At n is equals to 1, 2 is present, and n is equals to 2, 3 is present, and n is equals to 3, again 1 value is present in the input sequence. So in input sequence, the minimum value of n is 0. Okay, so n is starting with 0 and n ends at 3, right? Okay, so similarly we need to identify the range of this n value in output sequence y of n. Okay, so for that purpose, initially we'll identify total number of samples in y of n. Okay, so I'll write here total samples in y of n. So how will you identifying it? So simply you need to add the length of x of n plus length of h of n minus 1. Okay, so that will give you the total number of samples in y of n. Total number of samples in h of n are 4. Okay, there are 4 samples in h of n. Similarly, 4 samples are in x of n, right? So what will be the length of x of n? X of n length is 4. Similarly, the length of h of n is 4 because there are 4 samples minus 1. So it will give you 7. So in y of n, total number of samples in y of n will be 7. Okay, so the length of y of n will be 7. Okay, so how to identify? So that is the first thing that we identified here, that is the total number of samples in y of n. So there will be total 7 samples, right? Similarly, we need to identify, just like in this case h of n is starting from minus 1, that is n is equals to minus 1. Here x of n is starting with n is equals to 0. Okay, so the start time for h of n is minus 1 and the start time for x of n is 0. Similarly, we can identify the start time for y of n. Okay, so we'll be identifying start time for y of n. Okay, so how it will be identified? So we'll be adding the lowest limit of x and lowest limit of h, or you can simply say that start time of x and start time of h. Okay, so here we are adding lowest limit of x plus lowest limit of h, right? So this is how you are identifying the start time for y of n. That is nothing but you are adding start time of x and start time of h. So the lowest limit in h of n is minus 1 and lowest limit in x of n is 0. Okay, so 0 plus minus 1, so it will be simply minus 1. So the sequence y of n will start from n is equals to minus 1. Okay, and as there are total 7 sample, okay, so the values of n will vary in y of n as n is equals to, it will start from minus 1, then it will be 0, then 1, then 2, then 3, then 4, then 5. Okay, so there will be total 7 samples that will be present at n is equals to minus 1, 0, 1, 2, 3, 4, 5. So these are the values for time, okay, small n, right? And there will be sample values of y of n present at these different time intervals, right? So at origin there will be some value, right? But this sequence will present from minus 1 to 5, so total 7 samples will be there. Okay, if you count these values, so this will be 1, 2, 3, 4, 5, 6, 7. Total 7 values will be there, and it will start from minus 1 to 5, right? So this is how you are identifying total number of samples and the start time for the output sequence y of n. Okay, so next, now we'll be identifying the actual sample values in the given sequence. Okay, so for that purpose, again here what we are using the convolution summation formula. Summation k is equals to minus infinity to infinity, but now it will be from Okay, minus infinity to infinity, and so this is the convolution formula that we are writing. Y of n is equals to k is equals to minus infinity to infinity x of k into h of n minus k, right? So the convolution operation, that is convolution of x of n with h of n, okay, it is represented as y of n is equals to x of n star. Okay, star is the operator used for indicating the convolution operation. X of n convolved with h of n. Okay, and with formula it can be represented like this. Okay, and as convolution is the commutative operation, so convolution of x of n with h of n is same as h of n convolved with x of n. Okay, but the difference only in this operation is that x of n will be kept as it is in the convolution formula, and folding and shifting operation will be performed on h of n. Okay, as we have seen in the previous session, there are different operations involved in the convolution operation. So we are using folding, then shifting, then multiplication, and then summation. Okay, so but when you are convolving x of n with h of n, so in that case you are performing folding and shifting operation on h of n. But when you are convolving h of n and x of n in this form, so h of n will be kept as it is, but folding and shifting operation will be performed on x of n. Okay, so you can decide as per the given sequences which sequence will be selected for the folding and shifting operation. Okay, here if you observe in the given example, so both sequences comprises only 4 samples, so any one of these sequence can be folded and shifted. So here you can use the formula, that is the convolution formula, where the impulse response is folded and then shifted by n, right? So this is the convolution formula, but as we know that the value of n here, okay, value of n is varying from -1 to 5, right? So that means we need to compute y of n for these values, right? From where these values we have computed, so that I have shown in this previous slide. Okay, so there are total 7 samples, but the values of n are starting from -1, so -1 to 5 will be total 7 values will be there, right? So for these different values of n, I need to compute this y of n. Okay, so initially obviously we'll start with the n is equals to 0, then we'll start n is equals to 1 2 3 4 5, and then for n is equals to -1 we'll compute. Okay, so for n is equals to 0, what formula you will get? So you will get y of 0 is equals to, again, summation k is equals to minus infinity to infinity x of k into h of minus k. Okay, so in the given example, your x of k will be same as x of n. Okay, so what is the given input sequence? So it is 1 2 3 1. Okay, so that sequence I had to take here, 1 2 3 1. Okay, and origin is at first one here. Okay, so this is the origin, so this is my x of k in this case. And what is h of k? So h of k will be same as h of n. Okay, simply I am using different variables here. In place of n I am using k. Okay, in place of n I am using k because n I have used in the output sequence here. Okay, so again h of n is 1 2 1 minus 1. Okay, so it is 1 2 1 minus 1, and origin is at this 2. Okay, so this is the origin. Okay, so these are the given sequences, right? So for n is equals to 0, if I am substituting n is equals to 0 in this formula, so this is the given or this is the convolution formula, right? So as per convolution formula, if I am substituting n is equals to 0, so I will get y of 0 is equals to summation k minus infinity to infinity x of k into h of 0 minus k, that means h of minus k. So to get this y of 0 value by using graphical method, what we'll do, initially we'll plot these sequences, that is nothing but h of k and x of k, right? So here I can plot h of k right? H of k. Okay, on x-axis I will be representing time k, on y-axis I will be representing actual sample values, that is h of k. And similarly I can plot the values of input sequence, that is x of k I will be plotting, right? Okay, so again here I can represent, as you can see, h of k. If you observe h of k, so it is starting from -1, 0, 1, 2, right? So 0, 1, 0, 1, then 2, 3, and so on. Okay, but there are only limited values. Okay, there are total number of only 4 samples. It is a finite sequence, it is not infinite sequence. Okay, so here on left hand side of the origin you can take -1, -2, okay, -3, likewise values. Similarly here you can take 0, 1, 2, 3, 4, similarly -1, -2, likewise. Okay, so here to plot these values, okay, I'm representing the given impulse response and the given input sequence graphically now. Okay, so initially I will plot h of k. So h of k at -1 it is 1. Okay, so at -1 it is 1, correct? At 0 it is 2. Okay, at 0 it is 2, right? At 1 again it is 1. At 1 it is 1, right? And at 2 it is -1. So at 2 it is -1. Okay, so that is h of k, right? Similarly I can plot x of k. Okay, so as per the given input sequence, at origin it is 1. Okay, at 0 it is 1. Okay, then at 1 it is 2. So at 1 it is 2. Then at 2 it is 3. So at 2 it is 3. And then again at 3 it is 1. So at 3 it is 1. So this is how I have plotted the given impulse response h of k and the input sequence x of k. Okay, so after plotting these two sequences, as per this formula, when I substitute n is equals to 0, so y of 0 is summation k minus infinity to infinity x of k into h of minus k. Okay, so here x of k is there, right? X of k is already present here. Now I have to identify h of minus k. So h of minus k is nothing but the folded version of h of k. Okay, so I need to fold this h of k. Okay, so here I will represent this h of minus k. Okay, so h of minus k can be obtained from this uh, h of k. Okay, so this is nothing but your folded version. Okay, so about origin you will get same samples. So again 0, 1, 2, 3. Here again represent -1, -2, -3. Okay, and to plot these values again I have to fold the given h of k about origin. Okay, so origin sample will be as it is. So at 0 this same value will be there too, right? We have seen this folding operation in previous sessions, right? So at origin 2 will be there, right? The value present at time unit 1, now it will present at -1. So at -1 this one value will be there. So at -1 1 will be there, right? Similarly the value present at n is equals to 2 or k is equals to 2, now it will be present at k is equals to -2. So at -2 you will get -1 value. Okay, so here you will get -1 value. Okay, at -2. Similarly the value present at -1, now it will be at 1. So at -1 it is 1, so at 1 it will be 1. Okay, So I simply folded this sequence about origin. Okay, so these values which are present on the right hand side of 0 now will be present on left hand side of 0. The values present on left hand side of 0 will be present on the right hand side. Okay, so this is h of minus k. Now we need to simply, as per this formula, we need to simply multiply x of k and h of minus k. Okay, so we'll be multiplying these two sequences, that is x of k and h of k, and the will multiply it. Okay, and the multiplication result I will plot here, right? So again, on x-axis I will be plotting k, and this multiplication sequence I will represent it as v of k, just for product sequence. Okay, v of k, but I am plotting it for, or this multiplication I am identifying for n is equals to 0, so I will specify it as v0 of k. Okay, so that is the multiplication sequence I am representing. Okay, so how to multiply it? Again, as I am graphically plotting it. Okay, so again 0 will be there, 1, then 2, then 3, similarly -1, -2, -3. Okay, so just I will multiply these two sequences, that is h of minus k and x of k, and draw or plot its multiplication sequence, that is represented as v0 of k. Okay, so at origin you will find in x of k it is 1, and in h of minus k it is 2, so 2 multiplied by 1 will be 2 value. Okay, so it will be 2 at origin, right? So why 2? Because at origin at 0 it is 1, here at 0 it is 2, so 2 multiplied by 1 will be 2. At 1 it is 2, here also at 1 it is 1, again 2 multiplied by 1 will be 2 value. At 2 it is 3, at 2 no value present means 0 is there, so 0 will be there, so it is 0 here, right? Similarly at 3 it is 1, but at 3 no value means 0, so again at 3 it is 0, right? Similarly on negative side, so at -1 0 is there, right? So at -1, so it is 1, so again 1 multiplied by 0 will be 0, right? So 0. At -2 it is -1, at -2 no value means 0, right? So again it will be 0. Okay, so only these two non-zero samples will be there in multiplication result when you are multiplying x of k and h of minus k. Okay, so that is the product sequence comprising two non-zero samples at n is equals to, sorry, at k is equals to 0 and k is equals to 1, and at both places the value is 2 and 2, right? So after multiplication you have to sum these values. Okay, for k is equals to -infinity to infinity, you have to sum these values, that is product sequence. Okay, that means where y of 0 will be what, summation of k is equals to -infinity to infinity, this x of k into h of minus k were represented as v0 of k. Okay, we are summing these values, so the summation of these values will be simply 4, that is 0 plus 0 plus 0. At other values of k the value is 0 except at k is equals to 0 and 1, so 2 plus 2 4 added with all zeros. Okay, so it will be simply 4. So at origin we have computed this value. Okay, so at origin, that is at n is equals to 0, the value of output sequence will be 4. Okay, so in this way you can identify the output sample for various values of what you can say, various values of n. Okay, so similarly next here we identified it for n is equals to 0. Next we have to identify it for n is equals to 1. Okay, so when you are substituting again your convolution, no need to rewrite this formula again and no need to redraw these graphs again, but to get better understanding I am rewriting this formula here, right? So y of n is equals to, what is that, summation k is equals to -infinity to infinity x of k into h of 1 minus k. Okay, so n minus k. Okay, So now I have to identify, as your n is varying from -1 to 5. We already identified it for n is equals to 0 here. Now you can substitute it, n is equals to 1. Okay, so for n is equals to 1, formula will be y of 1 summation k is equals to minus infinity to infinity x of k into h of 1 minus k, right? Okay, so we already have this x of k. Okay, x of k is already there, right? We already plotted here x of k. Okay, x of k is already plotted here. Now we need h of 1 minus k. Okay, as we have seen in the previous example, if there is a positive value of n, then h of k will be shifted, sorry, h of minus k will be shifted right. Okay, we'll be shifting this h of minus k to right if n is positive, and if n is negative, then we'll be shifting it to left. Okay, so to obtain this h of 1 minus k, okay, because we already have this x of k. Okay, again, if I want to plot it here, so same sequence is there, right? So x of k with k, what is the input sequence? So your x of k, that is nothing but your x of n, comprising these 4 samples. So what are those samples? So it is 1 2 3 1, right? So 1 2 3 1, origin at this first one. So same sequence will be there, right? 0 1 2 3 minus 1 minus 2. So at 0 it is value 1. Okay, at 1 it is 2, at 2 it is 3, at 3 it is 1 again. Okay, okay, so that is x of k. Now I want to obtain h of 1 minus k, right? So h of 1 minus k can be obtained from h of minus k. Okay, so what we have to do, we have to shift this sequence on right. Okay, so that means this sample will go at 2, this sample present at 0 will be at 1, minus 1 sample will be at 0, minus 2 sample will be at minus 1. Okay, so likewise we will be drawing this h of 1 minus k, right? So 0 1 2 3, similarly minus 1 minus 2. Okay, so the value present at this value present at 1 will be at 2, so at 2 this value will be 1. Okay, so at 2 the value will be 1, right? Similarly, the value present at 0 will be at 1 now, so at 0 2 is there, so at 1 2 will be there. Okay, so at 1 2 will be there, right? Similarly, the value at minus 1 it is 1, so it will be at 0 now, so at 0 it will be 1. Okay, then at minus 2 it is minus 1. Okay, so it will be at minus 1, so at minus 1 it will be minus 1. Okay, so this is h of 1 minus k. Okay, so again you need to multiply these two sequence as per the formula, right? We are multiplying x of k with h of 1 minus k. Now we'll multiply these two sequence. Okay, and multiplication result I will be plotting here. I can represent it as v1 of k. Okay, because we are identifying it for n is equals to 1, so it will be v1 of k. So again 0 1 2 3, similarly minus 1 minus 2. Okay, again I will be plotting these values, okay, of multiplication result. Okay, so at origin here it is at 0 is it is 1, at 0 it is 1, so 1 multiplied by 1 will be 1 at origin. Okay, so at origin you will get 1, at 1 it is 2, at 1 it is 2, so 2 multiplied by 2 will be 4. Okay, at n k is equals to 1. Then at 2 it is 3, at 2 it is 1, so 3 multiplied by 1 will be 3, right? Similarly at 3 it is 1, at 3 it is no value, means 0, so it will be 0 multiplied by 1 will be 0 in this case. Okay. Similarly, for minus 1, it is 0. Here minus 1, it is minus 1. So minus 1 multiplied by 0 will be 0. So this value will be again 0. So this is nothing but your v1 of k, that is product sequence. You are calling it as what? Product sequence, v1 of k. So here you got it as what? Summation k is equals to minus infinity to infinity x of k multiplied by h of 1 minus k, right? So this is nothing but your product sequence minus infinity v1 of k. So simply you will be now adding these values. Okay, you will be adding all these values present in this sequence. So 0 plus 0 plus 1 plus 4 plus 3 plus 0, it will be simply 8. Okay, so y of 1 you got the value 8, y of 0 we get the value 4, for y of 1 it is 8. Similarly you can identify it for n is equals to 2, right? So for n is equals to 2, formula will be y of 2 is equals to summation k is equals to minus infinity to infinity x of k into h of 2 minus k. Okay, so again we have this x of k will be same sequence. Okay, here x of k is the given input sequence, right? So x of k is, again it is 1 2 3 1 1 2 3 1. Okay, so at origin it is 1, so 1 2 3 1 values are there, right? So 0 1 2 3 minus 1 minus 2. Okay, so that is x of k. And to get this h of 2 minus k, okay, h of 2 minus k, so you can, to get this h of 2 minus k, you can shift h of minus k right by 2, or h of 1 minus k, you can shift h of 1 minus k to the right by one sample. Okay, so h of 2 minus k can be obtained from h of minus k or h of 1 minus k. If you are obtaining it from h of 1 minus k, so you will be shifting h of 1 minus k 1 by right. Okay, so you have this h of 1 minus k, so this sample will be now at 3, this sample will be at 2, this sample will be at 1, and this sample will be at 0. Okay, so likewise you will be obtaining, or if you are obtaining it from h of minus k, so h of 2 minus k will be, you will be shifting this sample by 2, okay, to the right. So this sample will be at 3, this sample will be at 2, this sample will be at 1, this sample will be at 0, likewise. Okay, so we'll try to shift this by 1 to the right to get h of 2 minus k from h of 1 minus k. So this value which is present at 2 will be at 3 now. Okay, so 0 1 2 3 4, similarly minus 1 minus 2. Okay, so at 2 it is 1 here, right? So at 2 it is 1, so now it will be at 3. Okay, so at 3 it will be 1. Similarly at 1 it is 2 here, so this one, the value present at 1 will be at 2 now. So at 2 you will get 2, your same sequence will be there, simply it will be shifted by 1 on right hand side. Okay, in the right direction it will be shifted. So at 0 it is 1, so it will be at 1 now. At minus 1 it is minus 1, so it will be at 0 now. So it will be at 0, that value minus 1. Okay, so this is how you obtain h of 2 minus k simply by shifting the h of 1 minus k to the right by one sample. Okay, now again you will multiply these two sequences. The product sequence will be denoted as v2 of k now. Okay, that is, this is nothing but the product of x of k and h of 2 minus k, and 0 1 2 3 4, similarly minus 1, minus 2, minus 3, right? Again I will be multiplying these two sequences, that is x of k and h of 2 minus k, right? So at origin value is 1, at origin it is minus 1, so 1 multiplied by minus 1 will be this minus 1. Okay, at minus 1 in both cases no value is there, that means 0 will be there, right? Okay, at 1 here 2 is there, at 1 1 is there, so 2 multiplied by 1 will be 2, at 2 it is 3, at 2 it is 2, so 2 multiplied by 3 it will be 6, right? Again at 3 it is 1, at 3 it is 1, so it will be simply 1. Okay, so likewise you are obtaining the product sequence. So at 4 no value is there, at 4 no value, so it will be simply 0. Again to get y of 2, again you are adding all these values. Okay, so that means you are adding summation k minus infinity to infinity v2 of k. Okay, so if you are adding all these values, so it will be simply uh, that is minus 1 plus 2 plus 6 plus 1 0. Okay, so it will be simply 8, right? After addition you will get 8 result here for n is equals to 2. Okay, so that is the third sample that we obtained. Similarly for n is equals to 3, again y of 3 will be summation k is equals to minus infinity to infinity, then we will be obtaining x of k into h of 3 minus k. Okay, so again your x of k is same, right? X of k is same here, that is nothing but 1 2 3 1. Okay, so 0 1 2 3 4 minus 1 minus 2, so your x of k is 1 2 3 1, same sequence is there. Okay, okay, so at origin it is 1, at 1 it is 2, at 2 it is 3, at 3 it is again 1. Okay, so next you have to obtain h of 3 minus k. Okay, h of 3 minus k, so 0, then 1, then 2, then 3, then 4 5. Okay, then minus 1 minus 2 minus 3. Okay, so h of 3 minus k can be obtained from h of 2 minus k simply by shifting it to right by one sample. So this sample present at 3 will be at 4, sample at 2 will be at 3, sample at 1 will be at 2, sample at 0 will be at 1. Okay, so minus 1 no value will be at 0, so simply at 0 there will be no value, right? Again at 1, so the value present at 0 will be at 1. Okay, so at 1 it will be minus 1. Similarly at 2 the value present at 1 will be there. Okay, so 2 the value 1 will be there, right? Similarly at 3 the value 2 will be there. At 3 you will get this value, the value present at 3 will be at 4, so it is 1. Okay, simply it is you are shifting the h of 2 minus k by one sample to right, or you are shifting h of minus k by 3 sample to right. Okay, again you are multiplying these two sequences. Okay, so you will multiply it, and multiplication result you will plot here, you will represent it as v3 of k. Okay, so again write 0 1 2 3 4 minus 1 minus 2. Okay, likewise, so these multiplication results I will be plotting on this graph. So at origin here no value is there, right? So here 1 is there, so multiplication will be 0, right? At 1 it is -1, at 1 it is 2, so it will be -2. At 2 it is 1, at 2 it is 3, so it will be multiplication 3, right? At 3 here 2 is there, right? At 3 it is 1 there, so multiplication will be 2. At 4 no value is there, right? So simply 0, multiplication will be 0. Again you will be obtaining y of 3 by summing all these values, okay? Minus infinity to infinity vk of, that is v3 of k, right? So after summation you will get the result as 3 plus 2 plus minus 2, okay? So it will be simply 3, right? Okay, so similarly the remaining two samples on positive sides you can obtain, okay? So that is for n is equals to 4, again y of 4 is equal to summation k minus infinity to infinity x of k into h of 4 minus k, right? Again same graph for x of k will be there. I will simply plot it here once again. So x of k, okay? So 1 2 3 1 was the sample, okay? 1 2 3 1, okay? So that is 0 1 2 3 -1 -2, and to get this h of 4 minus k, again I will be shifting h of 3 minus k by 1 to the right, okay? So as per this sample, the sample's value will be same, that is -1 1 2 1, but it will shifted by one sample to right. So the value present at 4 will be at 5, 3 will be at 4, 2 will be at 3, 1 will be at 2, okay? The value present at 1 will be at 2, okay? So here I can represent 1 2 3 4 5 6, okay? So the value at 4 will be at 5, so at 5 it will be 1. Sequence is same, sequence is -1 1 2 1, so instead of starting it from 1 I'll start it from 2, so -1 1 2 1, okay? So -1 1 2, right? And 1 already plotted, right? So instead of starting it from 1 it is started from 2, right? So at 1 no value will be there, at 0 no value will be there, okay? That means 0 will be there. Again I will multiply these two sequences, represent this result as v4 of k, right? So it will be 0 1 2 3, right? 4 -1, okay? So when I will plot these multiplication result on the graph, then at 0 no value is there, right? So 0 will be there. After multiplication at 1 also, here no value, right? So 0 will be there after multiplication. At 2 it is -1, at 2 it is 3, so it will be -3. Then at 3 it is 1, at 3 it is 1, so multiplication will be 1, okay? At 4 here value is 2, but here no value means 0 is there, okay? So that means 0 will be there. So again after this no sample values present there, so basically 0 will be there, right? So y of 4 will be yours, again summation k minus infinity to infinity, you are adding all the product values in v4 of k, right? K is equals to minus infinity to infinity. So after addition you will get result -2 here. Similarly for n is equals to 5, okay? So same formula will be you are using. So y of 5 will be summation k minus infinity to infinity x of k into h of 5 minus k will be there, right? So again here x x of k is same sequence, right? Okay, so 0 1 2 3 4. Left hand side it will be -1 -2, again 1 2 3 1 was your sequence, input sequence, right? Now you have to obtain these values. Okay, k, that is nothing but h of 5 minus k. Okay, so here it was started from 2, now it will start from 3. Okay, so it will start from 3 4 5 6, 4 samples are there only. On 7 again it will be 0, right? So instead of starting it from 2, now it will start from 3. Okay, so again -1 1 2 1 values are there, so -1 1 2 1. Okay, 1 2 1. Okay, so again sequence is shifted by one sample on right. Here it is 2, here it is 1. At origin no value is there. Okay, so similarly at 1 no value is there, so here the values are 0. Okay, so again I will multiply this sequence, so it will be represented as v5 of k, right? And after multiplication I can plot results here. So at origin at 1, at 2, as 3 values are 0 here, so 0 will be there. Okay, at 1 here you can find. Okay, again okay, at 1 at 3 it is -1, at 3 it is 1, so it will be -1 simply. Okay, at 4 it is 1, but at 4 no value is there, so it will be 0, right? Again at this is at 3, this is at 4, this is at 5. Okay, again 0 will be, so only one sample will be there, right? So again y of 5 will be summation k minus infinity to infinity v5 of k. Okay, so it will be simply -1, so that is y of 5. Okay, so in this way you can obtain it for positive values of n. Okay, so because our n was varying from -1 to 5, so for 0 1 2 3 4 5 we identified. Now for n is equals to -1 we have to identify. Okay, so for n is equals to -1, we'll get formula y of -1 is equals to summation k is equals to minus infinity to infinity x of k into h of n minus k. So value of n is -1 minus k. So we have this h of minus k already present, right? But for your convenience purpose I will draw these both sequences here. So x of k, it is 1 2 3 1. Okay, so this is your x of k, so 0 1 2 3 4 -1 and so on. H of minus k we have obtained. Okay, h of minus k was the folded sequence, okay, that we have obtained already here. This was your h of minus k, so I will simply plot it. So it is it is starting from -2. Okay, -1 1 2 1, starting from -2. Okay, it is starting from -2. At -2 it is 1. Okay, sorry. So it is starting from -2 -1 0 1 2, right? -3. Okay, so if you observe here h of minus k, so values are -1 1 2 1, -1 1 2 1. Okay, -1 1 2 1. So this was your h of minus k, but we need now h of -1 minus k. So h of -1 minus k will be obtained from h of minus k simply by shifting it to left. Okay, this will be shifted to left by one sample. So these values will be now, the value present at 1 will be at 0. So this will be 1, then there will be 2 value. Okay, I am shifting it to left by 1. Okay, this sample will be at 0, this sample will be at -1, this sample will be at -2, this sample will be at -3. So this will start from -3. Okay, instead of -2, so it will start from -3, then -2. Okay, likewise values will be there. Okay, I will indicate it as -3, -4, -2. I will indicate it. Okay, so this is at 0, this is at -1. Okay, so at -1 these two values there, right? So the -1 value will be at -2. So at -2 1 will be there. Okay. Similarly at -3 this -1 value will be. So -1 1 2 1. Okay, so that is h of -1 minus k. Simply it is shifted by one sample in left. At 1 at 2 these values will be 0. So again simply I will be multiplying these two values to get the product sequence, which is represented as v minus 1 of k, right? At n is I'm identifying it for n is equals to -1. Okay, so it will be represented as v minus 1 of k. So again at origin value is 1, at origin value is 1, so this will be 1, multiplication will be 1, right? At 1 here no value means 0, at 2 no value is 0, so all these values will be 0, right? At -1 no value means 0, at -1 2 is there, again these values will be 0, -1 1 2, and this is about origin. So again you are obtaining y of -1, right? So here only one sample is there at 0, right? So summation k minus infinity to infinity p minus 1 of k, you are adding it. Okay, so after summing all these values it will be simply 1, right? So for y of 1 you got the value, you get the value 1, right? So finally you will be writing, therefore the response of given TTLTI system is, you will be listing all these sample values, right? Whatever you have got, okay, after computation. So as you can see here, so at n is equals to 0 it is 4, right? N is equals to 1 it is 8. So at n is equals to 0 it is 4, 8, n is equals to 1 it is 8, n is equals to 2 it is again 8, 3 3, right? So n is equals to 2 it is 8, 3 3, right? For n is equals to 4 minus 2, for n is equals to 4 it is minus 2, for n is equals to 5 it is minus 1, right? Similarly at n is equals to minus 1 it is 1. Okay, so these are the values, that is 1 4 8 8 3 minus 2 minus 1, the remaining values will be 0, right? Okay, so this is how you are performing convolution summation by using graphical method. Okay, what were done initially here, we initially identified the total number of samples in y of n by adding total number of samples in h of n plus total number of samples in y of n minus 1. So 12 plus 4 minus 1 will be 7, so total 7 samples will be there. The start value, time value for y of n has been identified as adding these lower limits. Okay, so it is minus 1 plus 0, it will be minus 1. So y of n will be starting from minus 1, it will end at 5 because total 7 values will be there, right? Then for different values of n, we have to perform folding shifting operation on h of k. Okay, x of k is as it is everywhere, but h of n will be folding and shifted depending on what values of n you are substituting there, right? So according to that, we have identified various values of y of n for different values of n starting from -1 to 5. And then we have listed the result in the output sequence. Okay, that will be the final convolution result or the response of the given system. Okay, LTI system. So this is how you will be identifying convolution summation by using graphical method. Okay, here is another example, right? As I have said in previous explanation that convolution of given sequences can be represented as y of n is equals to x of n convolved with h of n, or h of n convolved with x of n. Both are same. Okay, both are same. Only difference is that which sequence will be folded and which sequence will be kept as it is. Okay, so if I am using convolution of x of n with h of n, so the formula will be y of n is equals to summation k is equals to minus infinity to infinity x of k into h of n minus k. That means first sequence will be kept as it is, while second sequence is folded and then shifted. Okay, but if I'm using this second form, then in that case summation k minus infinity to infinity, it will be h of k into x of n minus k. Okay, so h of k is kept as it is here, but input sequence is folded and shifted, right? So this decision you can take as per the given sequences of impulse response and input sequence. So which sequence on which sequence the folding and shifting operation will be simpler, according to that we will be using any one of this formula. Okay, so again in this example you have to determine the response y of n of a relaxed time invariant system with impulse response has been given, and input sequence is given as the unit step sequence. If it is not specified, then it will be specified in this statement itself. The input is unit step. Unit step means u of n, and you know that u of n is 1 for n greater than or equals to 0, and it is 0 otherwise. So that means for negative values of n, it doesn't exist. Okay, it is 0 basically, right? And for positive values of n, it is 1, right? Okay, so here initially we'll try to plot the graphs for these given sequences. Okay, that is h of k and x of k, right? So we'll try to plot this graph. Okay, so initially I will plot it for x of k, right? So your x of k will be same as x of n. Okay, so here I will plot it for. Here you cannot directly identify the start limit or start value of sequence, okay, as well as the at what time it will end, okay, because the value of n can vary. It can be anything which can be greater than or equals to 0, because it is 1 for these values, right? So to solve this example, okay, I'll take next slide because I have to plot these graphs. Okay, so initially I will plot x of k. Okay, x of k will be same as x of n, which is nothing but u of n. Okay, so I will be plotting it. So how it will be plotted? So here k will be there. Sorry, x of k will be there, and on x-axis k will be there. So as we know that u of n is will be 1 and 0, 1 for n greater than or equals to 0, and 0 otherwise. Okay, so here as per the given input sequence, it is nothing but the unit step sequence. Okay, so all values will be 1 for n greater than or equals to 0. So that means for k greater than or equals to 0, the values will be 1. Okay, Okay, so for n is k is equals to 0, it will be 1, right? Similarly, for k is equals to 1, again 1. Then for 2 it is 1, for 3 it is 1, for 4 it is 1, and so on. And for negative values of k, these values will be 0. Okay, so that is x of k, right? Similarly, the given input, the given impulse response h of n can be plotted by using this function. Okay, so h of n, which is nothing but your h of k now. Okay, so it is a to the power, what is that? A to the power n u of n. Okay, a to the power n u of n. We have plotted this exponential sequence for a less than 1. Okay, so basically a is given as this condition has been specified here, mod less than 1. So this value of a, you can take any value which is less than 1. Okay, so it can be 0 0.9, 0 0.8. Okay, likewise, so according to that its graph will be plotted. Okay, so again it is multiplied with u of n. Okay, u of n, that means it will exist only for positive values of n, right? If you are substituting any negative value of n, then u of that negative value will be 0. So the complete sequence will be 0, right? So you will plot it for only positive values of k in this case. Okay, so here you are plotting h of k, so it is nothing but your a to the power k u of k. Okay, here it is nothing but your u of k. Okay, so again as it is multiplied with u of k, so it will only exist for these positive values of k, right? And for negative values of k, again it is 0. Okay, okay, so how this will be plotted? We have already seen the plotting of this exponential sequence when we have seen elementary discrete time signal. But again, when you are substituting k is equals to 0, so it will be a raised to the power 0 multiplied by 1, because u of 0 is 1. Okay, so a raised to power 0 is nothing but 1. Okay, a raised to power 0 is 1, right? When you are plotting for k is equals to 1, so it will be a to the power 1 u of 1. U of 1 is 1, and a to the power 1 will be obviously less than 1. Okay, why? Because condition is given here, a is less than 1. So zero 0.9, if you are taking a value is 0 0.9, so it will be less than 1. Similarly, a square will be less than a, right? We have seen this thing already. Okay, a cube will be less than a square, right? And so on. So this is nothing but your h of k, right? So as I have specified in the previous slide, depending on these sequences, which sequence will be plotted or which sequence will be folded can be decided. So as per these octane graphs, okay, you can see that folding and shifting operation will be simpler on this sequence than this one. Okay, but it doesn't matter which one you are shifting or folding, the results will be the same. Okay, but here instead of using this formula, that is what y of n is equals to summation k is equals to minus infinity to infinity x of k into h of n minus k, I will be using y of n is equals to summation k is equals to minus infinity to infinity h of k into x of n minus k. Okay, so the folding and shifting operation I will be performing on input sequence x of n, right, instead of h of n. Okay, so I have to fold it. Okay, because I have to identify it for various values of n. N is equals to 0. I will get formula as y of 0 is equals to summation k is equals to minus infinity to infinity h of k into x of minus k. Okay, this formula I will get. So I have to fold this input sequence x of k. Okay, about origin, so how it will be plotted now, x of k. Okay, so the values will be present at 1 2 3 and so on, will be at now -1 -2 -3. Okay, and so on. So at 0 the value will be same, that will be 1, right? At 0 it will be 1. At -1 it was 0 initially, but these values will be shifted to on the right hand side of the origin. This value is present on the right hand side. Origin will be now at left hand side of the origin. So at -1 it will be 1, at -2 it will be 1, at -3 it will be 1, and so on. Okay, everywhere on left hand side it will be 1. At 1 it will be 0, right? At 2 it will be 0, at 3 it will be 0, right? So now I have to multiply these x of minus k, it is x of minus k, right? It is the folded version of x of k. So I have to multiply this x of minus k with h of k now. Okay, so this multiplication result I will indicate here. Okay, so this will be your multiplication. Okay, I will indicate it as simply v0 of k because I have substituted the value 0. Okay, so it is nothing but what, your h of k multiplied by x of k. Okay, these values, right? So at origin it is 1, at origin it is 1, so 1 will be there, right? Multiplication. Okay, at 0, sorry, at 1 a is present, at 1 0 is present, so it will be 0, right? At 1. Similarly at 2 3 it will be 0, and so on. At -1, here it is 0, here it is 1, so again multiplication will be 0, and so on. So that means for n is equals to 0, your y of 0 is 1. Okay, if you are summing all these values, so it will be 1. Similarly you can identify it for n is equals to 1. Okay, so again I will draw here the what, x of, because I am folding and shifting these values, x of 1 minus k. So x of 1 minus k I will be plotting, right? Your h of k will be same sequence. Okay, so that was 1, then a square, right? A cube, and so on. Okay, this was your h of k, right? In previous graph we have plotted it, same sequences there, right? 0 1 2 3, we are not performing any folding or shifting operation on it. Okay, okay, so this is h of k. Now x of 1 minus k, for getting x of 1 minus k I have to shift this one to right, okay, by one sample. Okay, so now 1 2 3 and so on. Similarly 0 -1 -2 and so on. Okay, so when I will be shifting it, to right by one sample, okay, so it will get shifted. So this value present at 0 will be at 1, -1 will be at 1. So instead of this 0 there will be 1, and on left hand side all values will be 1. Okay, so likewise I will be plotting it here. So at 1 1 will be there, now here it will be 0, and so on. So at 0 again 1 will be there, at 1 1 will be there, at 2 1 will be there. Okay, so all these values will be 1. Again I will be multiplying these values. Okay, multiply it, I will get the sequence as v1 of k, right? v1 of k will be obtained, right? So again at origin 1 is there, at origin 1 is there, so it will be 1, right? Multiplication will be 1. At 1 it is 1, at 1 it is a, so multiplication will be a. At 2 a square, so here 2 0, so it will be 0. Okay, and 0 onwards, so 0 1 2 3 and so on. On -1, here you can find 0, at -1 1, multiplication will be 0. So again -2 it will be 0. And when you will sum these values, so y of 1 will be again summation k minus infinity to infinity, right? So it will be what you are doing, h of k multiplied by x of 1 minus k. So if you sum these values, so it will be 1 plus a. Okay, so 1 plus a plus 0 plus 0, so it will be 1 plus a. So y of 1 is 1 plus a. Y of 0 was 1, y of 1 is 1 plus a. Similarly, you can identify it for n is equals to 2. So for n is equals to 2, formula will be y of 2 is equals to summation k is equals to minus infinity to infinity h of k into x of 2 minus k. Okay, we have this h of k as it is, right? So h of k, so it was 1 a, square, a cube, a to the power 4 and so on. Okay, so 0, 1, 2, 3, minus 1, minus 2, it was 0, right? And similarly you can obtain this x of 2 minus k, okay, simply by shifting this x of 1 minus k to right. Okay, so from 2 uh, on left hand side all values will be 1 from 2 onwards, okay, and from 3 onwards it will be 0. So again 0, 1, 2, 3, 4 and so on. It will be minus 1, minus 2, minus 3 and so on. Okay, so it was this value now will be shifted at 2. Okay, this value will be at 1. Okay, so from 2 to the left side it will be 1. Okay, and here it will be 0 and so on. Okay, so in previous case only up to 1 it was 1, now it is up to 2 it is 1. Okay, so again I will be multiplying these values to get this sequence. It will be indicated as v2 of k, right, because n is equals to 2 I have taken. So again at origin 1 is there, so multiplication will be 1. At 1 it is a, at 1 it is 1, so multiplication will be a. At 2 it is a square, at 2 it is 1, so it will be a square. At 3 it is a cube, at 3 it is 0, so it will be 0. At 4 onwards it is 0. So 0, 1, 2, 3, 4. Similarly at minus 1 it is 0, minus 1 it is 1, so it will be 0 multiplication, minus 2 again 0, 1, so it will be 0 and so on. Okay, so again this y of 2 will be summation k minus infinity to infinity v2 of k, right? So it will be 1 plus a square addition. Okay, 1 plus a square plus 0 and so on. So after will be simply 1 plus a square. Okay, so this is how you are obtaining the sample values in this case. Okay, because value of a is not fixed here, right? Okay, so what we have got here, so y of 0 we get the value 1. Okay, as we can see here, so y of 0 is 1, right? Then y of 1 is 1 plus a, so y of 1 is equals to 1 plus a. Then y of 2 is 1 plus a square, right? Y of 2 is 1 plus a square, right? So what will be the y of 3 then? Y of 3 will be obviously 1 plus a square plus a cube and so on, right? So finally if I want to identify for y of n, because ultimately I am interested in the y of n, that is total response of the system, so it will be 1 plus a square plus a cube plus and so on. You can see that as the value of n is here, okay, so value of n is 1 here, so a to the power 1 is there, n is 2, so a square is there, n is 3, so a cube, up to a cube terms are there, right? So it will be a to the power n. Okay, terms will be up to a to the power n, so that will be the final result of the given example. So the response will be 1 plus a square plus a cube plus and so on up to plus a to the power n. Okay, if I want to represent in the series form, so the same term can be represented as, this is nothing but 1 minus a to the power n plus 1 upon 1 minus a as per the mathematical sequence. Okay, this same series can be represented in this way. Okay, you can represent it in this form, right? So this is the final answers, okay, of the given problem. Okay, so today we have discussed two problems were solved it by graphically. Okay, but here you can write down the different statement. Okay, first slide is okay. Here you will say for n is equals to 0, you are identifying the sequence, okay, y of 0. Okay, the sample value y of 0 that you have to specify. Initially we'll plot the given sequences, that is the impulse response. Okay, you will write here plot the given impulse response and the input signal. Okay, then you will plot it. Then for n is equals to 0, this will be your formula, so therefore you will need h of minus k. Therefore now we'll fold the h of k about origin, so we'll get h of minus k. Then we'll multiply h of minus k with x of k to get the product sequence v0 of k. Then we'll sum all the product outputs to get the actual value of y of 0. Okay, so likewise you can write down the statements right in the solution. Okay, so here in the solution finally you need to write down the final response of the system y of n. Okay, here the sequences are given in the functional form, right? Actual values are not given of the sample values are not given here, right? So still we have obtained the or plotted the sequence. Okay, here we have seen that you can use any one of these two formulas. Okay, depending on which formula you are using, the particular sequence will be folded and shifted, right? You can decide it from the given input and impulse response, which the folding and shifting operation to be carried on which sequence. Okay, so here we have carried it on the input sequence, but in previous problem we have carried it on the impulse response. Okay, the folding and shifting was carried out on the impulse response, but in this second example we have carried it on the input sequence. Okay, we have folded it and subsequently we have shifted it, right? So then we have obtained the individual responses here, right? So y of 0 is 1, y of 1 is 1 plus a, y of 2 1 plus a square. So according to that we can say that y of 3 will be 1 plus a square plus a cube, and similarly y of n will be 1 plus a square plus a cube plus and so on plus a to the power n. So that will be the final answer, or you can represent in this mathematical function. Okay, so in next session we'll be looking at the remaining methods of finding convolution summation, which is used to identify the response of the system. Okay, so ultimately in every problem, if you observe here, what has been asked, determine the output y of n. Okay, never even in the first example. Okay, what has been asked, it has been asked determine the response of the system. It has not been asked identify convolution. Okay, but we can identify the response of the system by using convolution. Okay, so in problem it will not be explicitly mentioned that identify the convolution. If it is mentioned, then obviously we will be identifying the convolution, but if it not been mentioned, if it has been mentioned at identify or determine the response, then obviously you will be using convolution for identifying the response of the system. Okay, so in problem you will be asked for identify output or identify response of the system, then you can use convolution. Okay, so in today's session we have seen first method, that is graphical method. In next session we will be discussing tabular method for identifying the response of the given system by using convolution sum. Okay, so thank you for joining this session.